Hi there guys, Miss Rocky's here today to teach you another math mini lesson. Thanks to the joy of the internet and other technologies, I can now teach you no matter where I am. I'm sitting in my RV right now, getting ready to teach you all about place value. Place value is a way of grouping numbers. Now I know you're going, no it's not, it's your ones, tens, hundreds, Miss Rocky, and you're right. It is 365 equals 3 hundreds plus 6 tens plus 5 ones. That's the way we currently talk about place value, and that's because we're using groupings. We have grouped our ones into tens and our tens into hundreds. Now, a long time ago, we didn't necessarily have those groupings already set up, and so people had to struggle with how do they count, where do they make that grouping. One of the best things that humans ever did to help us in understanding numbers was by adding a zero. They invented a zero. Zero not necessarily standing for a zero as in I have none, but more standing for a place value of I have no extra. So when we started counting, we generally counted things that were important to us. Sheep, cows, chickens, eggs, whatever it is that we were using. So today we're going to count sheep. And we let our sheep out into the pasture. They're all grazing and enjoying their day. Now we're going to bring them home to keep them safe from the fox. We want to make sure all of our sheep came home, right? So we've got to count them. And the easiest thing to do is to count using our fingers. Every time a sheep comes through, we put a finger down. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh wait, now all of my fingers are down, but I've got more sheep coming. Well, what do? Well, now I can say I have one set, and I'm going to add in that zero. I have one complete set of fingers and zero extra. That zero becomes a placeholder. That gives me the number 10. That way, when the next sheep comes in, I can put a new finger down and say, okay, now I have one set of fingers plus one finger. And when the next sheep comes through, I can say I have a set of fingers plus 2 fingers. And eventually, we in turn used that to be 11 and 12. So counting really is just grouping things into sets so that we don't keep going and going and going forever. Instead, we can see this as one complete set and 2 extra fingers. Now the number 12. Okay, so that's how I'm saying that place value is simply grouping. Okay, today we don't always use our fingers to count. Instead, we use base 10 blocks and we use large numbers, knowing that those numbers stand for something. Okay, you might be used to seeing these little teeny tiny ones blocks. You take 10 teeny tiny ones blocks and group them together, and you have a long skinny tens block. And then you take your long skinny tens blocks, put 10 of them together, and you have 100. 100 is equal to 10 long skinny tens blocks or 100 individual teeny tiny ones blocks. It all works together because we've used those groupings in a set way. And then if you wanted to take 10 of those hundreds, you get a big 1,000 square. So you've got 1,000 square that is 10 hundreds flats. By knowing that these are what these numbers stand for and that zero pushes us over in place value, we are able to talk to other people about numbers in a way that they understand and we understand without having to go, well, I filled up my hand 10 times, or, it's a lot easier for people to understand and communicate, and that's part of the reason for our current base 10 system. Okay, now, are you ready? We're going to have a mind-blown moment. Ready? Are you sure you're ready for it? Okay, here we go. Mind blown? There are other ways to count except base 10. Did you know that? We always count to 10, right? You count up to 10, or you count up to 9, really, and then you put the 1 and move it over, and now you've got 10. And then when you have 10 groups of 10, you get 100, and so on and so forth. That's what we just did. But there are other ways to count besides that. These are called bases. Okay? This is base 4. In base 4, you always start at 0, so you've got 0, 1, 2, 3. Wait, I've gone 4 numbers, and so now I have one group of 4 and a 0. That's not 10 the way that we would think of it, which would be one full group of 10. This is one full group of 4 because we are in base 4. And then what you would see as 11 is actually what we would call 5 because you have one full group of 4 and one more, and that's 5. And as you can see, we keep on grouping all the way down. That's base 4. You could also have bases that are bigger than 10. Okay, this is base 12. Now the issue with this in our system is that when you get to 9, you need another number for 10 because you haven't hit a group of 12 yet. So we started at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us 10. We don't have 12 to group in yet, so we've actually added in these 2 additional numbers to help us understand. And so those will be what we call 10 and 11. And then when we get to 12, you really have one group of 12 and 0 left over. Mind blown yet? Can you see it? Do you understand it? If you don't, it's okay. This is extra. This is not a part of your traditional you'll be tested on lesson, but it's a great way to help you understand what those numbers really mean. Okay? And if you ever are thinking of a career in computers, maybe in computer programming, you might start to see numbers like these. These are called base 2 numbers or binary numbers. And these are what computers have been developed on. It was originally developed on on-off switches, and so you'd have a 0 and a 1. That would be 1, and then you'd have it'd go on and on from there. But this is base 2. Can you imagine counting where you only had 2 fingers, right? So you've got 0, 1, and then by the time we get to 3, you've got a group. So you've got a group of 1 and a 0, and no leftovers. And then when you get to 4, you've got a group of 1 with 1 leftover. And then if you look over there, you've grouped your groups. So those numbers get long really, really fast. Mind blown moment. I hope this has stretched your mind. Hope I've not confused you too much. If I have, put it out of your brain. Come back and watch it later. Or don't worry about it. It won't be on your reflection. All right, time to move on. Coming back to what we know. Base 10 blocks. 1, 10 ones makes a 10. 10 tens make 100. 10 hundreds make 1,000. Every time you get to 10, you got to change place values because we are in base 10. Remember that. That 10 is very, very important. All right. So now it's time to take that place value reference sheet, go ahead and glue it into your notebook that has your ones blocks, your tens blocks, your hundreds blocks, your thousands blocks. You will notice in the ones section it also says units. Some areas of the world we call these little teeny blocks ones. In some places we call them units. It really doesn't matter as long as we remember that that is that base that we start with. When we get to 10 of them, we group them into 10. Okay? When we get 10 tens, we group them into hundreds. When we get 10 hundreds, we group them into thousands. And as you see, we don't have base 10 block drawings for them, but you could add your own. When you have 10 thousands, you get to 10 thousands. When you have 10 thousands, you get to 100,000s. And when you get 10 100,000s, you get to millions. Okay, so hopefully that will help you understand how to read numbers a little bit better. This will also help us learn how to compare numbers. Okay, so down at the bottom you'll see this chart here. It says starting at the far right, each place value we move to the left is 10 times bigger than the ones before. Okay, that helps us. If you line up your numbers, you can always know if it has more place values than the other number, it automatically is bigger. It's more than 10 times bigger, right? Because you had to have 10 to group it up there. So we're going to look on this next screen up specifically at that page for comparing numbers. We're looking at when you have 2 numbers, the one with more places always bigger, always. So 2,345 has 4 places, 234 3 places, automatically bigger. You don't even have to compare the numbers. Count the places, it's bigger. Okay, 7,549 4 places. 37,549, we have 5 places. 4 places, smaller than 5 places. You don't have to look at anything else, just count the places. Okay? Now, if you do have 2 numbers where they have the same number of places, that's when we have to start lining them up. Write one under the other, and look, compare those numbers. 82,165, 81,256, both have 5 place values, so we start at the 8s. 8, 8, they're the same. We're going to look to this next smaller. 2, 1. Okay, now we have a difference. Now we can look. Which is bigger? 2 is bigger than 1. 82,165 is thereby bigger than 81,256. Okay, looking at the next sample problem, we've got 3,489. 5,489. Both have 4 place values. Both have the same number. So let's start with the biggest. 3, 5. Oh, we got lucky. Okay, well that's easy. 3 is smaller than 5, and we can look there. All right, it's time for a spot check. Take a minute now and see if you can solve this problem. Did you try it? Did you pause? Please press pause and try it. Okay, we're going to go over it now. Which is larger, 45,002 or 42,005? Both are 5 place value numbers, so we can't just count the places. What do we need to do? Well, we need to look. The 4's are the same, so let's look at that thousands digit. Which is larger, 5 or 2? 5. If you told me that 45,002 was larger, you got it correct. Give yourself a pat on the back. All right, one more. Which of these numbers is smaller, 82,120 or 82,102? Pause the video, try it first. Did you pause it? I hope you did, because here we go. All right, which one is right? Well, again, they both have 5 place values. We can't just count. We look at the 8s, they're the same. We look at the 2s, they're the same. We look at the 1s in the hundreds place, they're still the same. So we're going to actually go all the way down to the tens place. We've got a 2 and a 0. The 2 is bigger, and so 82,102 is the smaller number. All right, guys, it's reflection time. Go ahead and take your reflection and glue it into your notebook. Let's take a look at what our options are today. Option A, write a paragraph explaining how to compare numbers, just like we just did. Option B, write 5 numbers and draw a picture of each one. Use those base 10 blocks. Option C, create a table or a diagram to teach someone else how to compare numbers. When we teach, we learn. Option D, choose 10 numbers larger than 50, don't use those baby numbers, and put them in order from least to greatest. That is comparing numbers, it's just a step up. Option E, write a number that has digits all the way to the millions place. Color code each digit, so perhaps you could say the ones place is going to be red, and the tens place is going to be blue, and the millions place is going to be purple, however you want to do it. But make sure you create a key for your code. Other people have to learn from it. You have to be able to come back and learn from it. Remember, reflection time is about building on your learning. Don't forget, once you've reflected, take time to think about your reflection. Ask yourself, did my reflection show thinking about this week's concept? Has my reflection followed all of the guidelines? And will my reflection help me review my thinking at a later date? That one's important, guys. Don't forget that one. All right, that's the end of today's video. Go take time to do your reflection. Thank you for watching. For more of these math mini lessons, check out our YouTube page. Follow our blog. You can also find links to all of the sheets shown in this mini lesson in the video description. Have a great day. See you next time.